Alright, in this lesson we're going to be talking about the atmosphere and you. What is the atmosphere, how does it work, and so on. So to start off, our atmosphere is 78% nitrogen, 21% oxygen, and 1% gas, other gases. That includes water vapor, carbon dioxide, ozone, and other various gases. But obviously we enjoy oxygen, helps us breathe. So that's what our atmosphere is made of. The three main gases, again, nitrogen 78%, oxygen 21%, other gases 1%, making a total of 100%. Atmosphere is a mixture of gases itself. Ours, in particular, as we just saw before, is three main gases. Certain planets have other mixtures of gases, but aren't specific enough to hold life on. In addition to containing the oxygen that we need to breathe, our Earth's atmosphere also protects us from the sun's harmful rays. Yeah, in the summer we enjoy Earth's rays, but if the atmosphere wasn't there, we'd either burn significantly bad during the day with very high temperatures, or freeze at night without the comforts of the blanket. Before we get into the Earth's atmosphere, we need to talk about density, okay? How dense something is. And I had pointed out before that if you have a gallon of air versus a gallon of concrete, which is more dense? Again, it's similar size, but we know that a gallon of concrete would be more dense. It's more packed in, more material packed into the same space, therefore being heavier. So when we say dense objects sink, less dense objects float. If you think about the Earth's atmosphere, about 1,000 kilometers up above you, there's a lot of air molecules being pulled down by gravity. That air molecules being pulled down by gravity would seem like a lot on our shoulders, but it's spread out. It doesn't feel like there's a bowling ball sitting on the tip of your finger. Instead, it feels like everyday life. You're just walking around. So this isn't exactly what it feels. Even though we have the pressure of all that air on top of us, again, it's spread out. We don't feel like it's at a single point. As altitude increases, air pressure decreases. The atmosphere is held around Earth by gravity. Gravity pulls gas molecules in the atmosphere towards Earth's surface, causing air pressure. Again, gravity is a center-seeking force, so it pulls the atmosphere down towards the center of the Earth. Now, if we take a look at this, air pressure is the measure of the force with which air molecules push on a surface. So we have the air sitting above us. The pressure that we feel depends on how compact, how dense the air is above us. It's strongest at Earth's surface, and we can see that in this diagram. Each one of these little dots represents air molecules. We can see at 0 altitude that the density of the air molecules is great. It's very compact, there's a lot of them. But as we go up in altitude, we see that the density starts to thin out. There's not so many in the same spot. So if we think about down here, think about this as the gallon of concrete. And then as we get up, think about this as a gallon of air. Again, it's less dense. Therefore, at Mount Everest, we need to wear oxygen masks because we can't breathe the same amount of oxygen we can at sea level. It's less dense, it's not as concentrated, therefore, again, pressure decreases with height. An easy way to remember this is to think about a human pyramid. Again, a human pyramid is based on more people on the bottom that you can build up on top. It's denser on the bottom and gets thinner as the layers go up. We look at four major layers of the Earth's atmosphere. Troposphere, which is the layer that we breathe oxygen in, okay, is also the layer in which all our weather takes place. And tropo just has to do with circulation. That's where the air mixes. Sphere just meaning circle. As we go up in height in the troposphere, from Earth's surface up to where temperature changes, we decrease our temperature with height. Now once we get to the stratosphere, strato meaning layered, that means there's no real mixing with the air. planes typically fly right above the troposphere and the stratosphere because we don't experience the turbulence that we would experience in the troposphere. In the stratosphere, we start at the top of the troposphere, and then we go up. Our temperature increases in the stratosphere. What's very important in the stratosphere that also manipulates the weather on Earth is the jet stream. The jet stream can move at 200 miles per hour at times. It's also the home of our ozone layer. Our ozone layer is found in the stratosphere. Now, our ozone layer is very important to us as it protects us from the sun's harmful rays. It absorbs the radiation that the sun gives off. So the reason why we have our mild temperatures on Earth is because we have an ozone layer that's just right, that absorbs enough sunlight, but allows enough to get down to us, which allows biology to take place. So once we get up to the mesosphere, again, we decrease temperature with height in the troposphere, increase temperature in the stratosphere, then we decrease temperature in the mesosphere again. Mesosphere is important. It's where we're going to see our shooting stars. They burn up in the mesosphere. And then our final layer in the thermosphere, our temperature increases again. Now, our thermosphere is very important for your cell phone reception. It's where we have our satellites, our international space stations up there, our shuttles hover around there. It's just far enough away from Earth, but still held within its gravity to stay around Earth and not float off into outer space.